In hybridization, we think about combining an s orbital with a p orbital and a p orbital and a p orbital to make either sp3, sp2, or sp hybridized orbitals depending on the combination. Now let's go back and think about the conventional carbon atom. Where do those electrons go? Well, we know that the 2s orbital should have 2 electrons, and thus that orbital will be full and shouldn't be involved in any bonding. Equally, we'll remember that one of the 2 p orbitals has no electrons and would equally struggle to engage in any kind of covalent bond. So what's going on with hybridization? Well, the theory says that the s orbital is raised in energy and each one of the p orbitals is lowered in energy until all 4 orbitals have the same energy. And this is what is being called the sp3 hybridized orbital. They are known as degenerate, the same energy. If we were to take each one of these orbitals and make a new bond between it and a 1s orbital of a hydrogen, we'd be making methane. And we would expect still for there to be only one energy. This is not what we find. When we analyze the ionization energies of methane, we find 2 ionization energies. So this indicates that the hybridization in this case is certainly not true. It was rationalized in 1932 by Linus Pauling, so we can be a little more forgiving that ultimately new data has arisen which suggests the theory is incorrect. And he went on in 1954 to get the Nobel Prize for Chemistry for this and other work. He's one of the few people to have been given more than one Nobel Prize after his second Nobel Prize for Peace in 1962. So why are we being taught about sp3, sp2, and sp? Maybe we should be describing this tetrahedral, trigonal, and diagonal. Well, this is a better description, but chemists take a lot to lose an old habit, and the sp3, sp2, and sp shapes are accurate. So in modern chemistry, it's often that we do talk still about sp3, sp2, and sp. So it's important to understand that idea, but it's equally important to realize that it's mostly correct, but it certainly isn't perfect, and maybe be aware where some of the flaws are in those ideas.